Hello everyone. As this is the day 4 of my training session, and I've got a couple of questions in the form of assignment. So let's just quickly dive into it. So the first question here is, what are different algorithms on which load balancer works? And explain at least 3 algorithms with example. So let us try to understand what is load balancer. As the name suggests, there is something called as load which need to be balanced. Website has got a lot of traffic, means they have been receiving a lot of requests. So these requests should be divided to many servers because a particular server cannot be used for all the transaction because it will be to that server. So the request should be divided to the servers equally on the basis that capacity which each server is holding. So to divide these requests equally, here we are using load balancer. Before the load balancer, there is a part called as firewall, where we can say it is sending the request to the authorized person. Coming to the algorithms, there is something called as round robin. Then next is the weighted round robin. Then comes the least connection. And there are two others which we can say it is something called as random, and another is weighted least connections. So let's just discuss about these. So the first here is the round robin. Here we can say that here we in the round robin there is like we'll be giving or we'll be sending the request to the servers alternatively. Like for example, the first request to the server one, second request to server two, then again the third request to the server one. But in weighted round robin, it is not this case. So here we can say that um, say for example, a server one has a lot of capacity, or we can say server one is 5x to the server two, as we can see in this weighted round robin. So here the first 5 requests will be moving to the first server one, whereas the sixth request will be moving to the server two. Then moving on forward, 7, 8, 9, 10, and 11 requests will be moving to the server one, and the remaining to the server two. And then the 12th to the server two. Here that is Here we can say that why we are using weighted round robin instead of round robin, as we had seen that if the server is of similar capacity, there is not a difference that we are giving it alternatively. If we are sending the request alternatively to the server one or server two. But if we say that server one is of high capacity and server two is of least capacity, or we can say that it is 5x, server one is 5x capacity to the server two, it means the server can handle, server one can handle 5x. It means the server one can handle a lot request rather than the server two. So if we divide this request alternatively, it means that it will be a load on the server two instead of server one. Server one will be, I guess it will be going too smooth, but the server two will be loaded and we might get a down in the server two. So yes, moving on to the third category, which is least connection. Here it is similar to round robins, we can say. Yeah, the request will be going alternatively at the start, but here we'll be seeing a factor which is connection. Say, for example, 1, 3, and 5 are online, and the 6, 4, 2 have been disconnected. So we can say that there is continuous traffic on the server one, whereas in server two there is something free end. So if we send the request alternatively, in server one there are 3 people who are online, and there is an empty end, or we can say it is somewhat free compared to the server one. So we'll be discussing about, so they'll be looking to the least connection and they'll be transferring the request further. Say if the 1, 2, and 3 are online in the server one, so the next request. So the next request will be moving on to the server 2. And there are other two where we can say that weighted least connections and a random. Random is like the load balancer will be randomly sending the request to the server 1 or server 2 or anything. And in weighted least connection, here it is a combination of weighted and the least. Mention at least 5 different use case where you think cron job is set in the application you use on a day-to-day basis, such as Instagram, FB, YouTube, Google, Flipkart, Amazon, etc. Here we can say that a cron job is a kind of a scheduler which will be set on the particular day or a particular period of a time. Say, for example, if you have set alarm. If I had fixed an alarm on the basis that I want to wake up at 5 o'clock, so the alarm will be ringing on the 5 o'clock as expected. So similarly, if the cron job is set on, say, for example, at 12 o'clock, so it means the server will run a particular code which will track the details or fetch a data and trigger a mail to the authorized person, whereas usually keep a track of the details given by this. Say, for example, we'll be consider. Okay, so we'll try to understand the application on a daily basis. Say for Google, here the Google uses something called as rank predictor. So the Google has set a cron job at 12 p.m., which means at the 12 p.m. the cron job will fetch the data, say for example, the traffic on a website, so that they can give a ranking to the website, which means that the rank of this my particular website should be at the rank 1 or it should be in the rank 2 or 3 on the basis of the traffic and the interaction between the client and the application. Say if you consider YouTube, the YouTube will be checking the followers count, or we can say that the subscribers count and the like count. And on the basis of this, they'll be deciding the rank on the YouTube. So similarly, we can say in Amazon and Flipkart, which are the e-commerce sites, here they will be keeping a track of the how many items have kept in the wish list, and they'll be triggering a mail to the authorized person wherein he can see the details and he can compare how many of them are interacting with our particular application. So similarly, on Instagram and Facebook, we can say that we can see in Instagram there is something called as a like tracking, or we can say there is something called as like button. See, if I'm an Instagram influencer and I want to see my particular day's reach, how much reach I'm getting on a particular day, or if I can say that I want to check how many followers I'm gaining on a particular day basis or a month basis. So here we can go through it. So yes, these are few uses of the cron job. So let's move on to the third question, which is create a document to explain New Relic dashboard with screenshots so that the video which you have watched, other person need not to watch and understand what are the different things on New Relic dashboard and what is their use. Okay, so here we'll try to understand what is New Relic. New Relic is basically a software as a service, we can say, which is a APM, which is application performance monitoring tool. This is a tool which will be managing, or which we can say, which will be optimizing the performance of the application. Say, for example, the response time of an application. It is basically a software which is at the service. We can say this as a APM, which means an application performance monitoring tool, which will be monitoring the performance of the website. Say, for example, if we get any errors at the middle, we can track this through the New Relic. Say, for example, at what period of time we have been getting this error. So let's just move on to the contents and the dashboard of New Relic. So here we can see that that is a time picker, server connections, web transaction, time chart, app desk, score chart, throughput chart, transactions, error rate chart, application activity, and the host chart. So let's just try to understand each category. So here we can see that there is something known as time picker, which means here we can select a span of time where we need to see the web transaction happen, which means here we can check the response time at this particular period of time. Here we can set in the range of from 0 to 30 minutes. Say for example, if we have set it from starting 10 to ending of 10:30. So then we can see this JVM kind of thing, which means here the application is written or the code is written in Java. So they have mentioned it as a JVMs, which is the Java virtual machine. Here, if we can see basically the host or how many servers we have been using. So if we click on this button, we'll be getting the drop downs on which server or which host we need to optimize, or we need to check the specification. We need to check on which we need to check the response time of the application. So it has a category which is at the below, which is JVM, which means which is in the blue color. So the JVM, which means it means that the response time is between this range. Then we can see something known as a web external and the response time of this. So if we want to just check the response time, so we can just untick this JVM and the web external thing. Okay. So we'll move on to the app desk score. Here say that the application is meeting our expectation or it is going beyond the application or beyond our expected or threshold. So yes, coming to the throughput, which we can say it is a graph which gives us the average or how many requests we have been receiving per minute. So this will be also in the range of time which we have been set at the beginning when the time picker. And yes, we'll be getting the average in this. So moving on to a bit below will be in transaction, we'll be getting the categories which is on the low response time, where we can see that here we can see that this is a login functionality which is consuming 1.210 milliseconds, and similarly other categories. So yes, clicking on this login, we can clicking on the login, we'll be getting a brief go through. So moving on to the error rate graph, here we'll be getting at what point of time we have got a particular error, where we'll be getting at what point of time we have got this error, and the response time of this error we can be calculating to this. So coming below, we'll be getting something known as host. So yes, similarly as in first thing I had explained that in the JVM part, if we click on the JVM part, we'll be getting the drop downs as how many hosts or how many servers we have been running. So this is something known as we'll be getting a brief abbreviation. We'll be getting a brief overview of the particular host. Say for example, a particular host is not in use. So here we can say that here we can trigger, or here we can keep a lambda function wherein if the CPU capacity, or we can say CPU is not running or it is at the 0%, we can keep a lambda function stating that the server should get shut down at that point of time. To the fourth question, which is list out different use where we can use AWS Cloud Watch. Yes. So speaking about the AWS Cloud Watch, we need to know about AWS EC2 instance, which we have created, which means it is basically an individual system, which will be in the cloud, which will be 24/7 and 365 days online. So here, when we speak about a cloud watch, AWS Cloud Watch is similar to New Relic, we can say, because these both are APMs, or application performance monitoring tool, application performance monitoring tools. The AWS Cloud Watch, we can say that these are used in many companies in keeping a track, or say for example, there is something called as a SendGrid, which is a provider of cloud mails, as they'll be transferring mails, like we can say, which has I think 70K, or so, I think it has 70,000 buyers, which will be sending and receiving the mails through this. Similarly, and as in New Relic, we have the time zones, or the categories in CloudWatch as well. So in CloudWatch, there is something called as alarms, which will be setting in the period of time, like at this period of time, this code or this Lambda function should be running. Say for example, to start an instance, I have kept a say for example, to start an instance, I have kept a Lambda function, and using this AWS CloudWatch, I'll be setting this Lambda function to a particular period of time, and on this alarm, this period of time, or on this alarm, we can say this particular Lambda function will run, and maybe it might start the EC2 instance, or it might close the EC2 instance. Individual cannot sit and be online 24/7 and 365 days, so that he might find the error, or he might get an error, or he might track the error at which particular time this error has been produced. So, and this, we can say that this is somewhat tedious task too, because any person can't sit 24/7 without sleep or anything, we can say that. So yes, here we'll be using AWS Cloud. That's it for today. Thank you so much.